Okay, here we go. Letter B. Now please realize, I do give you some harder problems from time to time to see what you'll do. Will you struggle and fight through? Or will you give up? Now, in higher education, you will be given lots of problems that you will struggle on. In fact, you might be lucky if you can even understand your professor. So, you could easily just go graph this one right now. You could find domain range and all that good stuff. Good luck finding zeros, but you could go graph that. But what we want you to do here is first the inverse. Remember, that means to take x and y and switch the locations, which should give you a hint of what's going to happen in the graphs. If x and y are switched, that was the reflection over the line y equals x from advanced math. And so if we switch them, we do that. But we have to solve for y if we're going to use the TI-83. Technically, if we're not going to graph this, there's your inverse. That's all you need to do. But we want to solve it for y. And so y is not by itself. And so we'll subtract 2 first. Now the y has to, for one thing, get out of the exponent. And another thing, we'd kind of like to get rid of that 3 if we could, so y was by itself. Luckily, we can do those 2 things in one step. Okay? And there is only one thing that'll cancel off a base of 3. That's a log base 3. Okay? So if I take log base 3 of this side, and here's what some of you didn't do, and I'd caution you on that, make sure you do put that in parentheses so you know what you're actually taking log base 3 of. Because without the parentheses, it might look like you're just taking log base 3 of x and then trying to subtract 2. Okay? Equals, log base 3 goes right here, 3y. Okay? So did I really take log base 3 of both sides? Yeah. Because remember, technically that can be brought out front if you want, or I know some of you just say it cancels and the y just falls down. Either way. There's your inverse. Again, it only counts as the inverse in this problem because, y to the -1, because that's what y is. Okay? Then you go ahead and graph them. I think that's something you can all do on the TI-83 and get them graphed and find out what's going on. But a rough sketch, because, I did bring mine with me. Rough sketch, it'll do something like that. And the other one will do something like that. So the first one is right here. What are the zeros on that? Yeah, so we're going to hit the 0. Because for that to actually hit 0 over here, it would mean that right here would have to say -2. This term would have to say -2, correct? And 3 to what power is going to give you -2? Nothing. There's nothing you can put in there. And some of you are saying, what about negatives? Yeah, 3 to the -2 is 1/9. Remember, it makes it unhappy? Okay, because that's never going to happen. And so then for domain and range, I probably should have colored my graphs, but anyways. Domain. Do they all eventually get used, I guess you could say? Range. Yep, not including 2 to infinity. Which then, before you even, if you graph this right, then you can always check, because down here, you should know these 2. Just by what you did on the first one, you should know those 2. Because remember, all you did was switch x and y. So just take whatever your range is and make it the domain. Does that make sense based on our graph? Again, this graph is over here now. 2 to infinity for the domain? It does. Again, not including 2, as someone said earlier. And range should be, according to this, -infinity to infinity. So what that means is basically these values right here will continue to grow very slowly, but will continue to grow and hit everything -infinity to infinity. Do you believe that? Yeah, I'm going to keep putting x values in. I'm going to keep putting them in, keep putting them in. This y value is going to slowly keep growing. And now, this one, zeros, you already told me there aren't any. This one, the 0 is, you can use your calculator. I think it actually is just 3, 0, because if you put 3 in here, 3 minus 2 is 1. Log base 3 of 1, it's saying 3 to what power would give you 1? And 3 to what power? The 0 power. So it is 3, 0. So coincidentally, if I were to ask you for the y-intercept of this one up here, 0, 3. See, just flip it. Yes, question. Basically, you'll probably, the easiest way for me is I actually look at the problem. Okay, I dig in a little bit deeper than just saying this one's that way, this one's that way. But if you have an exponential, you agree that's what this original was? They are which way? Horizontal. If they're logarithmic, they are. The reason is, though, is because, again, that would be vertical. If you try and make this to say -2 in this case, it's just not going to happen. Or in other words, can I make this, in other words, can I make this say 0? I can't even make it say that. No matter what x I put in there, it's not going to happen. Right? And then here, basically, I can put any x value in I want, right? Well, except for negatives, obviously, in this case. But so maybe that's not a good way of saying it. But logarithmic are going to be vertical, exponential will be horizontal. Yes? Right, that would be good. If you do both graphs at once, you mean? Yeah, if you look at both graphs at once, I know some of you were probably trying to, kind of throw that asymptote in there. But as it was just said, it's more of like half an asymptote. Or only an asymptote if you're talking about that graph, the one on the bottom here. It doesn't affect this one up here because they are two completely separate graphs. Now, if I were to combine these somehow, like in a piecewise, well, then I would tell you which pieces to graph where. And then maybe it would work for everything. Okay? But yeah, and then some of you were also trying to use this one. Yeah, but they're two completely separate graphs. I happen to have you put on the same graph. And the reason I do that is so that I can show you if I were to put that in, there's your reflection right there. Okay? So do you see how the asymptotes kind of reflect as well? How they do reflect onto each other? One way, yeah, kind of like an x, yeah. Like an x. If the y equals x happens to hit it somewhere, yeah. Which it should. Okay? Questions on that one? All right, this one was considerably harder because, well, even if you tried to find the zeros, your calculator would find one of them for you. It would find the other one if you hit the right arrow long enough. It would go find the other one. Or you could just calculate the other one. It's a lot quicker. All right? So this one right here, so based on what we learned on the last one, the one that's the original, will it have a horizontal or a vertical? Okay. A logarithmic will have a vertical. And you should be able to tell me where. Based on the problems we've done. Not 2. -2. With logarithms, you can look at what you're taking the logarithm of and make sure you're not taking the logarithm of 0. If I put -2 in there for x, I'd be taking the logarithm of 0. Not good. So you could graph that one again, go for that. But we have a problem. Then do any adding and subtracting you can first. Now what? This is the one that I tried to tell you what to do. I didn't want to exactly show you what to do, but how can we take care of that? Yeah. You could try the natural log, but I think it's going to make it worse. Okay? Because then you have a double log. We want to get it. Oh, I didn't even flip it yet? I should probably do that. So how about we start over? And I'll flip it first. So x equals log base 4 y plus 2.
Please come to the office.
Okay. So let's go like this, x plus 5, right? Because we want to get y by itself. Equals. Yes. Yeah. Make both of these sides exponents. And make them exponents with 4 as the base. 4? 4. Now they're all exponents. Because I needed a base of 4 cancel off my log base 4. And remember, when you have bases like this, they cancel. Does it cancel on the left side, though? No, because we don't want it to, right? So we've got 4 to the x plus 5 as an exponent equals y plus 2. So we're almost there. Now, what you do with the minus 2 is very, very important.
On the same level as the base.
Yeah, kind of the same level as a base is probably a good way of saying that. Or what some people do is they'll put parentheses around their exponent just to show, kind of like we did with the logarithms on the last problem, or even what we did with logarithms here. We kind of put parentheses around it to be very specific, or just make this just a really huge 2 so that you know. Okay? So there's your inverse. All right. And your graphs here. So this one's going to look something like and the other one well, it shouldn't have a little squiggle in the middle, but there you go. All right. So, which one? Yes. Oh, you would like to see how this is entered in a calculator?
Well, yes.
Oh.
What else did I Just start conversation.
Okay, here we go. Y equals log. Now, how is it that you do? For example, we got log base 4 of x plus 2 and then minus 5. Well, what should be the next thing I type in then? X plus 2. Yep, so x plus 2. And a very important key to hit next. Yeah, the parentheses. You got to close that thing off. Divide by. Very good. Not something you would suggest, but you do have to divide by log 4. Log 4. Close a parenthesis. Minus 5. Yep, that's exactly how you type it in. The calculator will know that those first two kind of go together. And then minus 5, that's how it'll calculate it for you. Okay, so now we got to go get the other one in there then. And we've got 4 then, caret. And then parentheses probably a good idea. And now that I've closed it off, then you can do the minus 2, correct? And I don't know where this is zoomed into, so I'm just going to kind of zoom standard here so that at least you can hopefully see something. That's about what I had, right? Pretty close? Give or take? Okay. Then you could use the calculator to get zeros. Okay. There's one for each. Believe it or not. This one right here, I do believe is at negative 4.5. Just dead on. There's no rounding at all. This one, unfortunately, obviously here's where that asymptote is for this portion. So yeah, that keeps going. This does keep creeping up that way. So it is actually going to hit way out there. But what's neat is if you were really clever about how you did things, you could have had that answer already. Because when you go to calculate zeros, it gives you a y-intercept, right? And it gives you the y-intercept of this one, which is going to be the x-intercept of the other one. It gives it to you right away without you even knowing it. If you just paid attention, it would have given you that answer. Okay? Yes? Okay? I will have to look at your calculator in a second. Let me finish the problem. Okay? So, domain and range, I think you're probably getting pretty good at that, right? Figuring that out. But zeros, this one here is negative 4.5. Let's go get the zero of the other one, because it's way easier just to calculate that one. So which is it that we don't have a zero for yet? Yeah, the regular one. We don't have the zero. So you might want to pay attention. We're trying to find the 0 that would happen somewhere out there, approximately Brooks's room. Right? So basically, we want this to be 0. Correct? I want the y value to be 0. That would give me an x-intercept. And so then we're going to add the 5 over. So 5 equals log base 4 of x plus 2. How do you solve it from here? You've already told me how. Base 4. So basically, it's 4 to the 5th equals x plus 2. So take 4 to the 5th and subtract 2. And that will give you the 0 for this one. Yep, it's 1022, 0. Again, had you paid attention when you did the 0 for this one, it always gives you that y-intercept first. I don't know why it starts there. It's in the program. That's where it defaults for whatever reason. And that would have been, as you reflect it, the x-intercept for this one. Okay. Okay. And I'll answer any questions with calculators in just a second.